Okay, so if you have questions, just feel free to pop in and ask and interrupt if you have questions. Basically, I'm just going to go through the basics of logarithms because that is really confusing for a lot of people, and then also kind of talking about how you enter it into the calculator, because every calculator is different, and you want to make sure you know where it is in your calculator. But first thing, we're going to just kind of start with the definition of a logarithm. It's basically the opposite of an exponent. So I'm going to just kind of flatten my tablet here. Move everything out of the way. So when we have exponential functions, we have something where you have some number, and then your variable, your x, is in the exponent, and then that is equal to another number. So it can be, some examples are like 2 to the x equals y. You can have any number underneath there that's called the base, and then the variable is in the exponent. So those are exponential functions. A logarithmic function is sort of the opposite of that. So if I change my y just to b, just for now, so actually let's just use my a to the x to the b, you could rewrite this as a logarithmic function where you have the log, and then it has a base a of b is equal to x. So the logarithm is basically, when you take a logarithm, your output is going to be the exponent. So it's going to give you what is in the exponent, and you can convert from one form to another. So if you have something in a logarithmic form, you can convert it back to exponential form and vice versa. So an example of what this might look like if you actually had some numbers. If you had something like 3 squared, so we know that 3 squared is equal to 9. So I'm going to just do that in a different color. If you were to rewrite that using the logarithm, you would say the log base 3 of 9 is equal to 2. So if you had the number 9 and you took the log base 3, it would give you that exponent, that 3 what equals 9. So it would give you that exponent, 3 something. So it's a way to kind of convert between these. You can convert something with exponential with a variable in the exponent, and we can remove the variable from the exponent by doing what's called a log.
Where did you get the 2 from? Like 3 times 3 equals 9?
That's coming from this exponent here. Yeah, so 3 times 3 equals 9. So the log base 3 of 9, it's sort of undoing it, and it's giving you what that exponent would be. 3 to what power equals 9? And then your answer is 2.
Easy enough.
Yeah, it's just a matter of understanding how to go from one to the other. So most of the time we have 2 different types of logs. We can have anything as a base, and that's basically just saying, okay, that's my number underneath the exponent. But we have 2 very common ones. We have log base 10, and if you just see log by itself, this is assumed to be log 10, log base 10, or 10 to some exponent is equal to something. So you're looking at powers of 10. If you don't have a number as a subscript underneath there, you're assuming that you're looking at powers of 10 and trying to figure out what the exponent is. So if you have something like you're asked to say, what is log 100? That's base 10. So we're saying 10 to what power equals 100? So 10 squared equals 100. So you would get, I keep somehow moving this in my hand. You would get an answer of 2, because 10 squared will give you 100. So if you have a calculator, depending on what type of calculator you have, I'm pull out my I have just a basic scientific calculator, and I have a button that just says log, and so if it says the word log and nothing else, it is assumed to be base 10. So if I was to just enter that in my calculator, I would just use my log button, type in 100, and get the answer 2. And so if you have a calculator handy, you can verify that to make sure that you're actually getting the correct answer there. Now the other type of log that we have is log base E, or natural log, and so that is ln. And I usually write it in cursive because otherwise it will look like this, and a lot of people think that it's a 1n, but it's in the letter L. So
I got a question. How do you do
yes.
the log 3 to the 9th or whatever, or log 3 9 equals 2 in the calculator?
Okay.
Scientific calculator?
That cannot be done on the calculator without a formula. So I will get to there. We have to use something called the change of base. Otherwise, the calculator only defaults to these two logs, log base 10 or the natural log. So ln, or it looks like 1n, but it's literally the L, is the natural logarithm. We use ln because it's actually, I think when you look at it in the French, it's logarithm naturel or something like that. So that's where the ln comes from. And so this is base E, and E is about 2.718, I think, if I remember that value correctly. Let me verify. Yes, 2.718. And so that would be saying that it's saying E to what power equals something. So E is our base. So David, you raised your hand. Do you have a question? Davis, do you have a question here? Sorry. Okay. Well, Davis, if you do have a question, you can type it into the chat box, or you can turn on your microphone and ask it that way.
Oh, okay. So I was asking if you have like a number that, for example, the homework that we have, I was a little bit confused. Like they don't show any like logs or any like natural logs. You have like a number, an exponent, x something equals to another number, and then how you gonna know you're gonna use natural logs, or you gonna use logs, or you just gonna do like the way it is?
Okay, so when you're solving things with logarithms, it depends on what the base is. I will actually get to that later, so let's hold off on that question. Right now, I just want to talk about I'm going to start with the definitions, and then I will get to some of these other questions. So if you just hold off there, I don't want to kind of jump around and then get too confusing. So I don't want to get to the solving part yet.
It's all right.
Okay. So going back to just definitions here. So ln is the natural log, and so that is base E. And on your calculator, you'll see like a ln button. And usually if you're taking a natural log of some number, like if I'm taking the natural log of 100, we don't know our powers of E, so you're going to get decimals. So I have an ln button, and I just type in the 100 and I get a decimal value. And we usually round to 3 decimal places. So if you did that on your calculator, you would get, if you took the natural log of 100, ln 100, you get 4.605. So those are the two basic ones, and that's what you have calculator buttons for. Now, Mike, you asked, what happens if you don't have you know, when you have a different base, because those are the only two that we have calculator buttons for, and that's where we have what's called the change of base formula. So change of base formula. So if you have some log base a of b, so that a could be like 3, 4 could be anything. This is equal to the log of b divided by the log of a. It is also equal to doing the natural log of b over the natural log of a. So you can do it in either way. You can use whichever button that you have access to on your calculator, and you can then convert from one base to another by using this change of base formula. So if an example of using this, if we had log base 3 of 9, that one where we should get 2, you would then instead do the log of 9 divided by the log of 3. And so like normally when we do logs, we'll do them in, you know, we'll do them one at a time. So the log base of 9 is 0.954. And then if I do the log of 3 on my calculator, I get 0.477. So when I divide those actually come out exactly to 2. So we got log base 3 of 9 equals the definition, where it's saying, okay, what is the exponent 3 squared, or 3 to what power gives you 9? But you can also find that out with your calculator by using the change of base formula. So there's no button for any base other than 10 or the natural log, so you then have to use the change of base formula.
Explained it just right for me.
Yeah, and if you want to, we can even verify that if you have to use the natural log instead. So the natural log of 9 is 2.197. Natural log of 3 is 1.097. 2.197, 1.097. And so this one didn't come out exactly. It came out to 2.003, but it's basically 2. It would come out to 2 exactly if I entered it in my calculator exactly as natural log of 3 divided by natural log of 9. If I didn't round, you do get exactly 2. But if you do end up rounding, it will be close but not perfect. But you do get the same answer using either one of these. So that's how you can then find the answer of different bases. This is change of base formula. And I'm going to actually highlight this formula so that it's clear, so that when I post this, the notes here, you've got that. So that's the change of base formula. Okay, so that's the basic of logarithms. So now Davis was asking about solving, how you solve things with logarithms. So solving with logarithms. So we can do two sort of things with logarithms. We can take an exponential equation and do a logarithm to solve, or you have something with logarithms and you kind of undo it. So I'm going to just start with a basic equation. So let's say you have something like, oh man, I need to watch where I put my hand. 4 to the x equals 500. So I don't know what power 4 to what power gives me 500. So when we're solving with logarithms, the logarithm gives you your exponent. So what you do is you take the logarithm of both sides. So we have a new technique to solve, and that's by taking the log of both sides. So you would have the log of 4 to the x equals the log of 500. So you're basically doing a log on both sides. Now on the right side, we can take our calculator and do the log of 500. So I have log 4 to the x, and then on that right side, I do that on my calculator, get 2.699. Now the question is, okay, so why are we doing this? We're doing this so that we can get this exponent out. We have a rule that says when you take the log, you can put the exponent in front. So this is, we have a property of logs, property of a logarithm, where log base a of, say, b to the x is the same thing as x times log base a of b. So this property says that if you have something in a log, the exponent can go out. So then what I have is x times log of 4 equals 2.699. So then I'm going to do the log of 4 on my calculator. So I have x times 0.602 equals 2.699. So we end up with 0.602x. I'm just rewriting the same thing that we have here. And now we just solve for x by dividing both sides by the 0.602. So I could take my 2.699 divided by 0.602, and I get 4.83. So when we have something with logarithms, the purpose, or if we have something with exponents, if our variable is in the exponent, we use a logarithm to remove the variable from the exponent. So when your variable is in the take the logarithm of both sides to get it out of the.
So how did you take the log of 4 raised to the x?
So I didn't take the log yet. It's just, so I just wrote it. So you know how when you're solving an equation, you could add something to both sides, or you can subtract something to both sides. In week 3, we learned that we could square both sides when we radicals. So you square it to get rid of the radical of the square root symbol. This is the same sort of thing. We have something with an exponent, so we're doing the opposite by doing remove the exponent. So you're allowed to write down the log sides, and then that means you're taking the log of both sides. Now, on the right side, you can just take the log of a number using your calculator. On the left side, we have to use that property that I wrote to the right, where your x, then in that exponent, that variable can go down in front. And then once the variable is in front, then you can take the log of 4 right there, because now your variable is in front of it and it's not in the way. And you can just put that in your calculator.
How about when you have the same base? Like you have like a log 4 exponent x equals like a log 4 exponent 25. So what do you do when you have the same base?
Okay, so if you have the same base, you don't even need to use a logarithm. So if you have something like 4 to the x equals 4 to the 25, or if you even have 4 to the, let's make that minus, 25 minus x, this is what's called the one, you use what's called the one-to-one property. And that is saying if you have a to the x equals a to the y, then x is equal to y. So if you have the same base on both sides, you don't have to take a log. You just set those exponents equal to each other. You have x equals 25 minus x. So you don't have to involve logarithms at all, because the base is the same, which means the exponents must be equal. So in this case, then, I'm just solving for x. So I'm adding x to both sides. And I get 2x is equal to 25. Then you divide both sides by 2. So you get x is 25 over 2. Or if you want, you can write it as 12.5. So if they have the same base, you don't have to do a logarithm. It's when there's one of them that has a base, one of them does not. That's when you need to start using a logarithm, because you can't use the one-to-one property. Does that answer your question?
Yes, you have answered my question. Thank you.
You're welcome. Okay, now the other type of solving where you're going to be using a logarithm is if you have a log in your problem already. So let's say I have the log of x plus 2 equals, and I'm really just making these up on the fly, so these are probably going to come out nasty, but that's fine. So if you have something like this and you have a log already in your problem, you need to get rid of the log. So here we're doing the opposite. So when we had something with an exponent, we took the log. If you have a log, you do the opposite. You're going to take an exponent. So you have to determine what base this is. So this is, we have here 10 because it's just a plain log. And so you're going to take 10 to your exponent to rewrite each side as an exponent. So I like to just kind of stick it underneath like this. So if I rewrote this, I have 10 to the log of x plus 2 equals 10 to the 500. So this is coming from another property of logarithms, is that if you have log base a to the a, those basically cancel out. Or if you have a to the log base a of, let's say 1, or let's say if I just put an x there, those cancel out and you're just left with x. So if you have a log and the base is the same as like the number, or if you have an exponent with a log in the, you have something with a log in the exponent and they have the same base there, they match, they essentially cancel out. So what happens here is if you have a log and then you raise it to the 10, that part cancels. And you're left with x plus 2 equals 10 to the 500. So we used 10 specifically to cancel out the log because the log is base 10.
Why you did not say on this side, why you did not say it's log 10, like the way you did the other side? Because I see you only put log to one side and you put a base 10. Why you did not add a log to both sides?
Because the existing problem that I have has a log on only one side. So I'm not taking the log, I'm doing the opposite now. So I'm starting with something with a log, and I want to get rid of that log, and so that's by taking exponents. So it's the reverse of what I did here, where I had something with the exponent and then I did the log on both sides. Here I have the log, so now I have to do the exponent on both sides. So I'm reversing the process.
All right.
Then would you minus 2 from the 10, or what would you do there?
Yes, yeah. So you would subtract the 2. You would first do 2 to, or 10 to the 500, which I think is going to be, my calculator can't even do that number. So I chose bad numbers there. I'll just leave it exactly as is. But you would subtract 2, and then you would have x is 10 to the 500 minus 2. Whatever 10, if I should have picked a smaller number. Oops, instead of 500 because it ended up giant. But yeah, you would just then subtract 2 from both sides in order to solve it. So I should, let me pick a different. Let's do a natural log. And let's say x squared equals, and then I'm going to have to pick smaller numbers, so I'll just pick 20 here. Let me make sure I can actually do that on my calculator. Okay, that's actually really big. So what if I just did 2? Okay, that's much more reasonable. Okay, so let's say I have the natural log instead. So our natural log is base e, so I want to take e and make those my exponents. So I just look at what the base is. So I'm going to have e to the natural log of x squared equals e squared. So the e and the natural log cancel out. So on the left, I just have x squared, and then on the right, I have e squared. So I'm going to do e squared on my calculator, and then a 7.389. So we have x squared equals 7.389. And then you're going to take the square root of both sides, so you can solve for x. And you're going to get a plus or minus. So you get x equals plus or minus, and then you take the square root of what you got, and we get 2.718, which actually ends up being e because the square root will cancel out that e squared.
That's what I didn't get before. Is how did you get the number from just like a letter? Like you had 4 raised to with the exponent of x earlier, and now you have just an x squared. How do you get the 7.389 from the x squared and the logarithm?
So the 7.389, that is what e squared is equal to. So I did e squared on my calculator. That's where I got 7.389.
But how do you do that on your calculator? How do you do e squared on your calculator is what I'm asking.
So I have a button that says e to the x. So my button is actually, let's see, I have to hit second, and then I have an LN button that I hit, and that gets me to e to the x.
Okay, I got that
So
too. I just didn't see it on my calculator. That's good.
Yes, thank you. That's a good question. And then like so the log 4, then I just typed in log, and then I hit in the number 4, and that gave me my thing. So this is basically, we can solve any bases. So I can even have something that's like, let's say I have log base 3 of x plus 1 equals 25. Let me make sure that's something I can do in my calculator, not too big. Oh, that's too big. Let's say we'll do 5. So if you have something that's not base 10 or not base 3, you're just looking at what is that base. So the base is 3, so that means I'm going to make 3 the number that I use under each of these. So I'm going to have 3, and then in the exponent, I have log base 3 of x plus 1, and then I have 3 to the 5th. And that log base 3 and the 3 cancel out. So I have x plus 1 equals 3 to the 5th. So I do 3 to the 5th on my calculator. I get x plus 1 equals 243. And then I just need to solve for x. So I'm going to subtract 1 from both sides. So I get 242. So it doesn't matter what base you have when you have something with a log. You just figure out what your base is, and that's what you're going to be using when you're creating your exponents. So if you have I know one of the questions on the assignment is, I'm going to move this over to my other screen. I want to open up my assignment, but I don't want to show you guys the solutions. That would be no good. Oh, it's going to open up on this window anyway. Let me cancel that. Then we will open up my template. That way you guys don't see the solutions.
I have another question for you.
Yes.
How do you do, like, on a written assignment? I'm not asking for the answer, but I'm like, it has like e raised to the 3x or like log 8 log base 8 or no log base 8.
This one right here? Yep.
Raised to the 3x minus 10. How do you do the 3x, or how do you do like 8 minus 2x or whatever like that on your calculator?
Okay, so here, so for this particular problem, they have the same base because they both have e's. So you're using that one-to-one property, where if the base is the same, that means the exponents are the same. So then
Yeah,
that's
easy enough. Then you don't have to solve that. Then that's easy enough.
Yeah. So yeah, this one right here, you would take the natural log of both sides. Because the natural log, it has base e. So I would take the natural log of e to the 3x, and then the natural log of 25.
That's what I'm saying. How do you get the natural log of e to the 3x on your calculator? Like, I don't get how to do the 3x part.
So you don't do that on your calculator. So because the natural log and the e, those cancel out, and that we use that rule where your exponent goes in front. So what happens is you're just left with 3x equals the natural log of 25. So you're never on your calculator going to take a natural log with a variable in it. You're going to use rules so that you get, so that whatever you're taking the natural log of, it's going to be just a number, and it's going to cancel things out so that you don't have a variable there anymore. So the natural log of e is just 1. That actually comes from this property of logarithms right here. So the natural log of e is equal to 1. So they just cancel out, so your exponent just kind of pops out right there. Whatever's in the exponent then becomes your answer for that part, because that would have ended up in front. So you're not solving anything with that. You're not taking a natural log of something with an exponent. You're trying to get that out of the exponent first in order to do stuff with natural logs or other logs or whatever you need to do.
I was thinking, how are you gonna find like natural log of 25? So if like I don't know how
You
you're
would
gonna
have to use your
calculate that.
calculator there. So you would have to type that into your calculator. Your calculator should have a natural log button, and so
Okay,
you can enter that in.
all right.
Yeah, it will just say LN on your calculator, so that's the button. So you don't have to figure out what that is.
So, like, without you writing it down, doing the number, doing C without you writing it down, you just take like you'd have like the 8 raised to the log of 8 times 3x minus 10, and then 8 to the log of 8 to the 5th, right? For the other one.
Yeah, but since they have, in this case, just like with the exponents that the base is the same, here the base is the same for logs, so you can actually set those equal to each other. 3x minus 10 equal to 5 because they have the same base. Because yes, if you do 8 to that, those will essentially cancel out, and all you're left with is the insides of the logs.
Okay, thank you. It's easier.
So,
It's easier once you like get the hang of the properties and stuff, I guess.
yes, yeah, it's the properties are the key, and the only two main properties you need to know are the highlighted ones that I have here, and then the one-to-one property is another one, and then this one with the exponent, where your whatever's in the exponent basically gets dropped down in front. So those are the properties you need to know, and once you have those properties, then you can pretty much do anything. And I should write down on the one-to-one property that we also have, if we have log base a of x equals log base a of y, then x equals y. So it applies also to logarithms as well. But yeah, once you know those properties, it's just a matter of applying the properties in the right way so that you can cancel things out, to remove any logs that you have, or to get your things out of the exponents as needed. For e here, in order to do anything, you have to first divide both sides by 4, so that you have natural log of 3x, and then you work the problem from there, where you're trying to get rid of the natural log. So you want to try to get your logs by themselves before you start undoing the logs by raising them to powers. And then I've gotten a lot of questions about like part B here, how you find the x-intercept. So the x-intercept is 1 f of x, f of x is equal to 0. So you are solving 0 equals log x minus 3 plus 1. So you're going to solve it with the same method that we've been doing, or where I've demonstrated. So first we want to get that log by itself by subtracting 1 from both sides. And then you have -1 equals the log of x minus 3, and then you're solving from there. And so that actually is very similar to this one right here, where you have log of something equals another number. So you would then go and solve for the x-intercept. You would do the same process, where here you would raise it to, you take 10 to that exponent so that it cancels out, and then you continue solving. And you would get like, you would have something that you can take a decimal of, or you'd have decimals, so that way you can get an actual number. I just accidentally ripped my microphone and headset out of my ear in accident. So do you guys have any questions? Any other questions? So you guys have been great asking questions.
I have a question about probably I did not understand how to find domain.
Okay. So here, this would have to be, so you want to know the basic domain of a logarithmic function. So let me try to find where that is in the textbook.
And also condensing and expanding by the properties of logarithms. What is exactly expanding and condensing different logarithms? Is that just solving if you're condensing, and then putting out the whole algorithm if you're solving or if you're expanding?
No, those are something different. So let me first, I'm going to bring over the textbook here. So this is all section 5.2 I've been basically going through. So when you have a logarithmic problem, your domain is always 0 to infinity. But if you have shifts, if you shift it left or right, your domain also shifts left or right. So if there's a transformation where you're shifting left by 2, your domain is now going to be -2 and to infinity, because you're shifting it left 2 places. If you have a transformation that shifts to the right by, like, say, 5, then your domain would be 5 to infinity because you've moved everything over by 5. So for this question about domain, you have to figure out how this was shifted, what transformations occurred to x, and then from there you can answer the domain. And these rules for transformations are exactly the same as transformations for other things where we've talked about, where you have a number added to x, you're moving to the left, and if you have a number that's subtracted from x, you're moving to the right. So when you figure out the transformation that occurred, then you just adjust the domain by the same amount. Okay, now the other question about the properties of logarithms. So these are exploring the actual properties, and they're basically using the same properties that I have done, but there's some additional properties. So these actually come from 5.3, and I've of this because I did talk about the change of base formula. So here's the change of base formula written there. But the other properties, so these are all of the rules. The ones I showed you the power property right here, where you take that exponent and you put it in front, because that's the most commonly used one. But when you are expanding or condensing, you're also using this product property and the quotient property. So the product property says if you have things that are multiple, them up with addition. It's sort of like you're distributing that log through and then adding a plus sign between each term. The quotient property is where you have something that's division, you turn it into subtraction. So when you are expanding, it's taking something on the left here and then making it longer by moving it to the right. If you're condensing, you're taking something from the right side here and you're turning it into something on the left. So you're going from one side to the other. I have in your classroom, let me double check so I can pull it up. So I know I have an entire on the properties of properties. Yeah, so I'm going to move. So I have a whole video on that section on 5.3 where I talk about those rules and expanding and condensing. And then I have 2 additional examples of how to do that. So I wasn't planning on covering that in this section because I already have videos for those. So for those last 2 problems, I would read these videos, and those should be very helpful for you. And those all come from section.
Okay, thank you very much.
Any other?
I think you covered everything I needed to know.
Yeah, I tried to. That was my plan. Thing that you would need to know basically for yeah, so I did. Those are covered in other videos, but I talked about this. I sort of talked about the transformation, and then I've gone over how to solve these kind of problems. Yeah, Nicole, I saw you raise your hand. Nicole, you can either turn on your microphone so you can ask a question, or you can type it into the chat box.
Can you hear me?
Yes.
Okay, are these slides going to be posted?
Yes. What I'm going to do is when I post the video, it processes and everything. In that email that I send out with the link to the video, I'm also going to include this. So I'm going to take this and turn it into a PDF and then attach it. So that way you'll have all of these notes available to you.
Okay, thank you.
You're welcome. Davis, yeah, you have another question?
Yeah, it's about the way they said to describe the transformation of the graph. Because I really don't understand. Friday, I trying to see if I can find like real video that can explain about this. I did not find it. Can you explain a little bit?
Yeah, the transformations, that goes back to week 4 where we've talked about function transformations. Where if you have a number that's added or subtracted to x, you move it left or right. If you have something that's added or subtracted to the function itself, it moves it up or down. If you have a number like in front, then that's a multiply, that's going to be a stretch or a shrink. So this actually, when it says the transformations, we're looking at what is happening here to x, and we're following the same rules of transformations that you talk about in chapter 4. So there's no specific video on it for this section because it's actually something that was talked about in a previous chapter. I should have said chapter 4. I meant week 4, chapter 2. So I would go back to, I think it's section 2.5 where they talk about function transformations. It's either 2.4 or 2.5. So I would go back to review those sections because that talks about what happens to x, what happens to y, and how those transform.
I have another question for you.
Yeah.
On our quiz this week, do you know if it's actually covering this chapter? Because last week we had a chapter that was covering the chapter before, and I was kind of surprised by that because I had notes that were really easy to do, and then the quiz was a lot harder than the notes that I already had planned that I thought were going to be on the quiz.
The quizzes always are on the week before because we want to make sure that you have your feedback on your assignment before you're quizzed on it. So every quiz has always covered the material from the prior week. So this week is going to cover the material from week 6 because now you have your feedback for week 6, and so you can review that before you take the quiz.
So we don't. So week 7 will not cover any of this stuff that we've learned today, but it will be on our final then.
Yes.
Thank you very much.
Mm-hmm. Yeah, Nicole.
Because when I looked last week, I did not see the slides for the last.
Right. So I had my live, no one showed up, so there was nothing for me to do. That's why there was no slides or anything, because nobody was there.
Oh.
Yeah. So I was like, well, I'm not gonna just talk.
Okay.
So that's why, yeah, that's why there was nothing last week. So I was actually worried that was going to happen again this time, but thankfully, you guys have showed up, so that means there's actually is going to be a video and slides.
Well, thank you very much. You covered everything for me. I appreciate your time.
Oh yeah, thank you. Yeah, so it's about 3 o'clock, so it's about that time. Thank you guys. I'm really glad. I am really, really glad that you guys were able to attend because I was like, I stayed on for an hour last week for week 6, and I'm like, nobody is here. So I was afraid. I'm like, what happens if nobody shows up again? So I am really glad that you guys were here so I can actually, go through and then answer questions and stuff. So I really do appreciate that. And I will let you know what I'm going to do for week 8, when I have that scheduled. But this might be, maybe I'll do this time again because this actually seemed to be really, a lot of you showed up for this time. So this actually might be the winner. So I might do the same time for next week.
Thank you.
Thank you very much. Appreciate it. Enjoy your weekend.
Thank you guys.
Thank you.
You too. You guys enjoy your Sunday.
All right.
Bye.
All right.